Okay, on this lesson we're going to continue to factor, but we're going to learn a couple of new things to do. So we've been looking at trinomials and factoring those and also binomials, but today we're going to see 4 terms, and so we're going to have to factor it. So if there's 4 terms, you're going to factor by grouping. So when you're factoring by grouping, your first step is to group the first 2 terms together, the second 2 terms together, after checking for a GCF. So really the first step is GCF. Then group the first 2, the second 2 together. You're going to factor out a greatest common factor out of the both groupings, and then you're going to be able to factor the rest of it. So first thing, we always check for a greatest common factor of all of the terms. Notice there is no GCF for all of them. So we're going to go to the first 2 and group them together, and then I'm going to group the last 2 together. So I want to find the greatest common factor of just the first 2 terms. So notice they have a 2 in common and then also an x squared. So I'm going to open parentheses like we've been doing, and I'm going to put what's left after dividing each one of those by that GCF. So that would just be an x plus, and then that would be a 4. So now you always bring down the middle sign, so bring down the plus sign right after that. And now I'm going to factor out the greatest common factor of the last 2 terms. So notice the GCF would be 3, and then that would leave me with x plus 4. Okay, so listen carefully. Anytime you're factoring by grouping, once you have taken out the GCF of the first 2, taking out the GCF of the second 2, these 2 binomials should match, okay? So now they have the x plus 4 in common, so you're going to write that one time, and then you're going to group these 2 together, which would be a 2x squared plus 3. And it doesn't really matter which one you write first. After you factored by grouping, make sure you're checking to see if you can go another step, and we cannot because it's not difference of squares there. So that's as far as we can go. So this is factoring by grouping. Anytime you have 4 terms, that's how you're going to factor it. Okay, let's take a look at another example. First, check for a GCF of all 4 terms. Notice they do not have a GCF of all 4 terms. So I'm going to group just the first 2, and then I'm going to group the last 2. So notice the first 2 have a 5 and a g squared. So when I divide each one of them by 5g squared, that's going to be 8g minus 1. Remember I said on the first one, bring down the middle sign. So I'm going to bring down that subtraction sign. The GCF would be 2, but I'm going to take a negative 2 out because it's a subtraction. So make sure you're dividing both of them by negative 2. So you should end up with an 8g minus 1. So remember I said the great thing about factoring by grouping, those should match. Since they have those 2 in common, you're going to take out that greatest common factor, which is the 8g minus 1, and then you'll just be left with those coefficients in front, which is 5g squared minus 2. Again, always check that. Make sure that you can't go another step with it. If you wanted to check your answer, you could always use FOIL, multiply it back through, combine your like terms, and then it should always give you back that original if that is the correct factors. Okay, let's take a look at another one. So this one actually does have a GCF of all 4. They all have a 2 in common. So I'm going to first start out by dividing all of them by a 2. So I have to put that 2 out in front. So that's 5h cubed minus h squared minus 35h plus 7. After I've taken out the greatest common factor of all of them, then I'm only looking inside. So ignore the 2 on the outside. I'm going to factor by grouping. So I'm going to group the first 2 and the last 2. So I'm finding the greatest common factor of those 2, which is h squared. That would leave me with 5h minus 1. Remember, bring down your middle sign. The GCF of those is 7, but we're taking a negative 7 out because we're bringing down that subtraction sign. So that would give us 5h minus 1. So notice these match. We write it one time, and then we're piecing together that h squared minus 7. And then don't forget about that GCF that you took out at the beginning, because remember, we want this answer to equal what we started with. So it's another way, factoring, remember, is just another way of writing a polynomial. So we're factoring it. Okay, let's take a look at another one. So let's see if they have a GCF. Looks like they do. So notice the greatest common factor would be 4, but also notice they all have a D in common. So I'm going to start out with dividing all of them by 4D. So I'm going to write my GCF out. So that leaves me with 3D cubed plus 3D squared minus 5D minus 5. Okay, so I'm only looking at the inside. There's 4 terms, so I'm going to group them. So notice the GCF of those two would be a 3D squared, which would leave me with D plus 1. Bring down your subtraction sign. GCF would be 5. When you take out a negative 5, you get D plus 1. So notice those match. We write it once. And then we're piecing together the other part, 3D squared minus 5. And then don't forget about that GCF that you took out at the beginning. Okay, you can always look to see if you can keep going. We do have a squared there, but 3 is not a perfect square and neither is 5. So that's as far as we can go. Okay, so this is factoring by grouping. Anytime you have 4 terms, that's how you want to factor. But the first step is always looking for a greatest common factor, no matter how many terms you have. So let's take a look at the back. Now, we're going to look at sum of cubes and difference of cubes. We've already gone over difference of squares, but now we're going to throw in 2 others. So anytime you have 2 terms, you will check for difference of squares, and then also sum and difference of cubes. So notice here that we are adding, so this would be called the sum of cubes. Perfect cubes. So a perfect cube would be something that is a number that is multiplied by itself 3 times to give you that perfect cube number. So 1 times 1 times 1 is 1, so 1 would be a perfect cube. 2 times 2 times 2 is 8, so 8 would be a perfect cube. Notice this one we are subtracting, so this is difference of cubes. So anytime you're factoring cubes, your answer will always look like this. It should be a binomial and then it should be a trinomial every single time. So to remember your signs, there's a way that you can remember it. It's SOAP. The first sign is always the same as your original binomial. So notice this is the same as this here. So that's always the same. Notice this one is the same here. The second sign is always the opposite. So notice instead of it being a plus, it's going to be a minus, or vice versa. If it's a minus, it's going to be a plus. So it's always the opposite. And then the last one is always positive. So that last sign is always positive. So that's how we can remember our signs when we factor cubes. SOAP, same, opposite, always positive. Okay, so let's look at our first example. We're going to factor it. There's 2 terms, so we need to check for, since it says cubed, we need to check for cubes. So 1 is a perfect cube, and so is p cubed. So I'm going to go ahead and set up. I always factor cubes with 2, and then I have 3 every single time. Don't forget that. That's what it should look like. A lot of students want to put 3 binomials, and that will never be the case when we're factoring cubes. So to get this first term, we're going to take the cube root of p cubed, which is just p. P times p times p is p cubed. We want to take the cube root of 1. 1. 1 times 1 times 1 is 1. We want to use the same sign. That's how we can remember. So same sign, so put a plus sign. To get this term, we are squaring whatever this term is here. So that's going to be a p squared. So you always square the first. The second sign is always the opposite. So I need to put a minus sign. To get this middle term, I'm going to multiply these two together to get this. So that's going to just be a p. P times 1 is p, but it has to be the opposite sign there, so it has to be a minus sign. To get the last term, it's always positive. The reason it's always positive is because you're squaring this one. So 1 squared is 1. So well, let me actually write the answer. P plus 1 times p squared minus p plus 1. So that we do the same process every time when we factor cubes. If you wanted to, you could distribute that, multiply them through, combine your like terms, and it should give me back that p cubed plus 1. So lots of terms would cancel out. Okay, let's take a look at part B. So notice we have two terms. They don't have a GCF. Remember, always check that first. They don't have a GCF. So notice they're cubes, and we're subtracting. 125 is a perfect cube. 5 times 5 times 5 is 125. So I'm going to set up my binomial and my trinomial. Remember, it's the same every time. To get my first term, I'm taking the cube root of j cubed, which is j. Remember to remember the signs, same sign on the first one, so bring your subtraction sign down. Cube root of 125 is 5. We already said 5 times 5 times 5 is 5. 125. Okay, so to get this term, this first term, we are squaring this, so that's j squared. To get the middle term, we're multiplying these together, which would be a 5j, and it would be minus, but it has to be the opposite sign there. So we have to put the opposite sign there, or the middle terms are not going to cancel if we were to check it by multiplying. So multiply them, but put the opposite sign. And then the last term's always positive because we're squaring this. Negative 5 times a negative 5 is a positive 25. That's why the last one is always positive, because you're squaring something. So again, you could check it by distributing. So you could distribute this here and distribute it here and combine your like terms. All those middle terms would cancel out. So this is my answer. I'll just write it better so you can see it. So again, when you're factoring cubes, it's the same every time. You should have a binomial and then a trinomial every single time. Do not put 3 binomials for your answer. It doesn't work that way because the middle terms, if you were multiplying, would not cancel. All right, let's take a look at another one. So we have two terms. There's no GCF. 27 is a perfect cube, so is 64. So I'm going to go ahead and set up my binomial and my trinomial. So cube root of 27 is 3. 3 times 3 times 3. Cube root of k cubed is k. So 3k times 3k times 3k should give me 27k cubed. Bring down my sign. Cube root of 64 is 4. 4 times 4 times 4 is 64. Okay, so to get this next term, I'm going to square this. So square it. 3k times 3k is 9k squared. To get the middle, we have to multiply these two together. So multiplying, we get 12k, but it has to be the opposite sign, so we have to put a minus sign. And then to get the last term, we're squaring this one, so 4 times 4 is 16, and it's always positive because anytime you square, you get a positive. Now, the great thing about cubes is once you factored, you can't go another step, so you won't have to check and make sure that that is the final answer. Okay? All right, let's look at another one. So this one here, notice they do not have a GCF. So two terms, 216. There is a cube root of that. That would be 6. 6 times 6 is 36 times 6 does give you the 216. Okay, so I need to set up my binomial and my trinomial because remember when you factor cubes, it's the same every time. So I'm going to use SOAP to remember my signs. So we already said the cube root of 216 is 6. Cube root of w cubed is w. Cube root of 1 is 1. 1 times 1 times 1. we're bringing down the sign, so bring down your subtraction sign. Remember, to get this term, we are squaring 6w, so 6w times 6w is 36w squared. We're multiplying these two, and we get 6w, but it has to be the opposite sign, so it has to be a plus. And then we're squaring -1 times a -1, which is a +1. So again, once you factor cubes, that's as far as you can go. Okay, so again, anytime you're factoring cubes, it has to be a binomial and a trinomial in order to multiply it together and it equal back this original. Okay, so let's take a look at part E. So I noticed they do have something in common, so this one does have a GCF. Always check that. GCF is 2, so I'm going to divide both of them by a 2. So that would be 1000 m cubed plus 27. So now looking at my two terms, I need to check for cubes because it says m cubed. I can take the cube root of 1000 and I can take the cube root of 27. So I'm going to go ahead and set up my binomial and my trinomial because that's how we factor cubes. The cube root of 1000 m cubed is 10m. 10m times 10m times 10m gives me 1000 m squared, or m cubed. Cube root of 27 is 3. We use the same sign. And then I'm squaring my first term. 10m times 10m is 100m squared. I'm multiplying these together, which is 30m, but it has to be the opposite, so we have to put the minus sign, and then we're squaring 3 to get 9. So again, it's the same process every time. Now, we want it to equal back our original, so we can't leave off that GCF. We always have to put our GCF out in front if we take something out at the beginning. We want those to be equal. Okay, last one. So look for a greatest common factor. They do have one. Let's see, 3. So 3 will go into both. So divide both of them by a 3. So that would be 8z cubed minus 27. So looking inside, we have cubes. 8's a perfect cube, so it's 27. So I'm going to set up my binomial and then my trinomial. So the cube root of 8z cubed is 2z. 2z times 2z times 2z is 8z cubed. Cube root of 27 is 3. Use the same sign, so bring down the minus sign. To get this, we need to square 2z. 2z times 2z is 4z squared. We multiply these two together to get 6z, but it has to be the opposite, so we have to put a plus. And then we square -3. -3 times a -3 is a +9. Again, don't forget about your GCF, because again, we want it to equal the original. So we could always multiply them back through, and it should give us back that original polynomial. So 4 terms we're factoring by grouping. 2 terms we're checking to see if it's difference of squares, which we did on the last lesson. And then this lesson, sum and difference of cubes. Let me know if you have any questions.